Greetings of the day. I'm Dr. K. Raghuram Mohan Reddy. The course name is Unconventional Machining Process. Today's topic is chemical milling procedure. Okay, right. At the end of this session, student will be able to understand the basic procedure for chemical milling. Okay, this is the course learning outcome of the today's topic. Okay, now let us look at this chemical process. Okay, so under this chemical process, what we are going to learn? Okay, right. Chemical milling. So usually chemical milling is the controlled chemical dissolution of the workpiece material by contacting with a strong reagent. Second one, special coatings called maskants protect areas from which the metal is not to be removed. Okay, so these are the basics. Just once I'm refreshing. Okay, now later we can jump to our main topic. The process is used to produce pockets and contours and to remove materials from parts having a high strength to weight ratio. Chemical milling consists of the following steps. So let me check whether this one is connecting to our main topic or not. Yeah. So these are the chemical milling steps. The first step already we have discussed in the previous presentation. Okay, preparing and pre-cleaning the workpiece surface. Okay, this provides good adhesion of the masking material and assures the absence of contaminants that might interfere with the machining process. The second step is masking using readily strippable mask, which is chemically impregnable and adherent enough to stand chemical abrasion during etching. Third step is scribing of the mask, which is guided by templates to expose the areas that receive chemical milling. The type of mask selected depends on the size of the workpiece, the number of parts to be made, and the desired resolution of details. Silk screen masks are preferred for shallow cuts requiring close dimensional tolerances. Wherever we need close dimensional tolerances, we have to go with silk screen masks. Okay, but which are very expensive, no issue. Fourth one, the workpiece is then etched and rinsed, and the mask is removed before the part is finished. Okay, right. Now let us look at this chemical milling setup. As usual, already we have discussed that the depth of etch is controlled by the time of immersion. This is utmost important one in the chemical milling. So this is the chemical reagent which influence the main removal of the material from the workpiece. Okay, here the mask is provided where the material will not be exposed to the chemical reagent, where the material cannot be removed. Okay, so here this medium will be with heating and cooling setup with this heating coil. In order to avoid uneven machining, the chemicals that impinge on the surface being machined should be fresh. So already we have discussed this one. The chemicals used are very corrosive and therefore must be handled with adequate safety precautions. Okay, so without adequate safety precautions, we should not involve in this chemical milling. Right. Both the vapors and the effluents must be suitably controlled for environmental protection. Okay, So agitation of the workpiece and fluid is usual. However, excessive solution flow may result in channeling, grooves or ridges. Next, inclination of the workpiece may prevent channeling from the gas bubbles. Okay, right. Bellows during 1977 reported that dishing of the machine surface occurred due to the uneven heat distribution resulting from the chemical action. Okay, typical reagent temperatures ranges from 37 to 85 degrees centigrade. Next, faster etching rates occur at high temperatures but must be controlled within plus or minus 5 degrees centigrade of the desired temperature in order to get a uniform machining. Okay, so in order to get uniform machining, we have to maintain plus or minus 5 degrees centigrade. Okay, right. Now, when the mask is used, the machining action proceeds both inwardly from the mask opening and laterally beneath the mask, thus creating the etch factor shown in figure 3. Okay, so here before etching, after etching. Okay, so before etching, knife angle. Okay, this is undercut. Okay, D. This is depth of cut, capital T. Okay, so when the mask is used, the machining action proceeds both the inwardly from the mask opening and laterally beneath the mask, thus creating the etch factor. Okay, so you can look at this. Okay, so before etching and after etching. Okay, the etch factor is the ratio of the undercut D to the depth of etch T. See here, this is undercut small d. Okay, so this is depth of cut capital T. Okay, the etch factor is the ratio of the undercut D to the depth of depth of etch capital T. This ratio must be considered when scribing the mask using templates. Okay, a typical etch factor of 1:1 occurs at a cut depth of 1.27 millimeters. Okay, deeper cuts can reduce this ratio to 1:3. Okay, so here what is etch factor here? The ratio of undercut to the depth of etch. Okay, right. The radii of the fillet produced will be approximately equal to the depth of etch. Okay, so here radii of the fillet, look at this figure once again. Here this radii of the, what is this? Radii of the fillet produced will be approximately equal to the depth of etch, that is capital T. Right. For simultaneous machining of multiple parts, racks or handling fixtures are frequently used to facilitate the submersion of the work in the chemical reagent and for subsequent rinsing. Okay, after rinsing the chemicals from the workpiece, the demasking is accomplished by hand stripping mechanical brushing or chemical stripping. See, already we have discussed that we are using muskets. Okay, so usually after the chemical reaction over the workpiece, we have to demask it and we have to mechanically brushing or chemical stripping. Some chemicals leave a film of smudge on the machine surface, which can be removed by other chemicals or frequently by brushing. See, usually for any process, it leaves some um, material, okay, or chemical, okay, that it can be removed by the other chemical process or simply by brushing. Right. Chemical milling will not eliminate surface irregularities, dents, scratches, or waviness. Okay, so chemical milling will not eliminate surface irregularities, dents, scratches, or waviness. Successive steps of mask removal and immersion, as shown in figure 4, can achieve stepped cuts. Okay, so successively we can get our required contours, that is nothing but stepped cuts. Okay, see here in the top one, this is scribe mask. Okay, so here first etching has taken place, so that here undercut has performed. Okay, next in this third stage, rescribe mask. Okay, so here masking has been modified so that some other performance, that means machining of the material, to be done. So here when we change the masking from here to here, what will happen? The material deterioration on this free surface has to be done. So that's what happened here. First plus second etching. Okay, this is first etching here. So when we change the masking, here also etching has been taken. Okay, so this is finally second etching. Okay, so first has been removed here. Okay, after the changing of this masking, okay, this is free open place, so here are this one extended like this. Okay, so this is first one, let us say some depth. Okay, that depth has been increased parallelly along with this one. Okay, so this is nothing but contour cuts by chemical milling. Next, tapered cuts. Okay, so look at this figure 5. Okay, machining tapers and steps by chemical milling. Okay, right. Taper cuts can also be produced without masking the workpiece by controlling the depth and rate of immersion or withdrawal and the number of immersions. Okay, so here for tapered cuts we need not go with masking. Okay, continuous tapers as great as 0.060 mm per mm for aluminium and 0.010 mm per mm for steel alloys have been machined on a production basis. Okay, now look at this figure. The first phase is immersion. Okay, so here no taper has been observed here. Okay, simply immersing into this solution. Next, constant withdrawal rate. Okay, so because of this constant withdrawal, that means after immersion we are withdrawing up. Okay, so what is happening? Some taperness has been noticed. Okay, right. So here we need taper that we have done. Suppose if we need steps, okay, stepped withdrawal rate. So instead of constant withdrawal, what we have to do? We have to use stepped withdrawal rate. Okay, for different steps, we have to maintain different times. Okay, right. These are the references associated to this topic, and thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.